Search in linked list. Searching in a linked list is the process of finding the position of a particular element in the linked list. If you have a linked list like this, how are you going to search and find out the position of any particular element? For that, you have to start from the first node of the linked list. Let me also mark the pointers here. First node, it will be pointing to the second node. The second node will be pointing to third node, and third node will be pointing to the fourth node. This is how a linked list is made. How are you going to identify which is the first node? For that, you have something called a head pointer. The head pointer of a linked list will always point to the first node of the linked list. This is also called as the head node. So whichever pointer is pointing to the head node is called as head pointer. This also serves as the identity of this linked list. That is, if you want to say this is my linked list, how do you identify this? You will say this is the head pointer of my linked list. You will provide the head pointer. If you want to pass this linked list to a function, you will be passing head pointer. So for all those purposes, head pointer is very important. How are you going to search? Let me put some numbers here. Here I'll have 17, 25, 13 and 36. Let us say I want to search for 13. I want to see whether 13 is present in this linked list, and if it is present, I want to return the position. What I'll do is I'll have a search pointer and I'll start the search pointer from the first node. I'm going to the head pointer and I'll see where is my first node present. Whichever be that position, that is where I am going to point my search pointer. Along with this, I'll also have a variable called position. Initially, this will be 0. I'll check in the first node whether the value in first node, that is 17, is this equal to what I am searching for. What am I searching for? I'm searching for 13. 17 is not equal to 13. What will I do? I have to go to the next node. How did I reach this next node? I will follow the next pointer of the first node so as to reach the next node. Whenever you are going through the next pointer, you have to do one more thing. This position has to be incremented. So from 0, it becomes 1. Again, I'll make the same check, that is whether 25 is equal to 13. I'll find out that it is not equal. What will I do? I'll again follow the next pointer to go to the next node. Whenever I am passing through the next pointer, what do I have to do? I have to increment my position to 2. Previously it was 1. Whatever be the value, I have to do plus 1. So here from 1 it became 2. What is the next step? In this node, the third node, I'll again have the same check whether this is equal to 13. Here it is equal to 13. What should I do? I can do two things. One is that I can return a pointer to this node. If I'm returning a pointer, whoever made the search, they can directly access this node because I am returning a pointer. Otherwise, I can return this position. I'll say it is at second position. So whoever wanted to search, they know that in this linked list, in the second position, I have 13. Second position in the sense, first position is 0, then I have 1, and then I have 2, then I have 4. This is how, 3. This is how I'll put indices. Next thing is, in case the element is not present, how am I going to understand that? For that, let us say instead of 13, I was searching for 40. In this case, it won't be found here. What will I do? I'll move on to the next node and I'll increment position to 3. This time, again, 36 is not equal to 40. What will I do? I'll again try to go to the next node. But this is the last node. It doesn't have a next pointer. The next pointer of this node will be null. So, whenever I see that next pointer is null, I'll understand that my list is completed. I have gone through the whole list. Even after doing this, if I'm not able to find this value, what does that mean? This value is not present in the list. So if I'm able to find this somewhere in between, I'll report that position. Otherwise, I'll say that in my linked list, this particular value is not present. This is how I am going to search in a linked list. What is the time complexity of this operation? If I want to search, what can happen in the worst case? In the worst case, I may have to start from the first node and keep searching in all the nodes, and even after that, I may not be able to find. Then, time complexity is order of n. Even if I find in the last position, then also I am going through all the n nodes and time complexity will be order of n. What about the space complexity of search? For searching, you are not using any additional space. Because of that, space complexity will be order of 1. So your time complexity for search in a linked list is order of n, and space complexity for search in a linked list is order of 1. Next thing is, whenever we know about an algorithm, we have a process, we should be able to convert this into a code. In order to convert this into a code, you may prefer any language. What I'll do is, I'll provide you a pseudocode. From the pseudocode, it's very easy to convert and implement it. So whenever you want to implement, you should have a pseudocode. Once you have an idea of the algorithm, it should be easy for you. I'll write pseudocode for this. Let us say it's a search function. I want to search in a linked list. So linked list is identified by the head pointer and I'll have a target value. What will I do now? First thing is, I should have a search pointer. I had a search pointer which was going through all these. For that, I'll initialize something called a current pointer. So my current, I'll call as C. Current will be initially pointing to head. Whatever is my head pointer, that is what I'll make as the current. So my current pointer is pointing to whatever is my head node. What will I do next? I'll have something called position. I told you, you should have a variable called position which will be initialized to 0. What should I do now? I can start a loop, and in this loop, what should I do? I should keep going through each of the nodes while checking whether that node is holding the value I am searching for. How can I do that? While my current pointer is not null. When I say while current, that means while current is not null. That is, if current is having some value. What will I do then? In this case, I will check whether the data inside current is equal to the target. So initially it is pointing to head. That is the first node. I'll check if whatever is the data in current. See, current is a pointer. So pointer is pointing to this. If I want to see what is the value, I will have to do current pointing data. This is how I'll see what is the value inside current pointer. If this is equal to the target value, what should I do? If this is equal to target value, if it is equal to target value, whatever is the position, I can return that. I will return position. If it is not equal to target value, then what should I do? I have to move to the next node. How can I move to the next node? I will say current is equal to current pointing next. Each node will be having a next pointer which is pointing to the next node. So current pointing next will make me point to the next node. So from here, my pointer is now reaching here. This is the procedure. While this loop is running, what will happen? In each of the loop, I'll keep going to the next nodes. One more thing is, I have to increment position. So let me increment my position here. Position is equal to position plus 1. I told you whenever you are doing next, you have to increment the position because then only you have a track of what number node you are presently visiting. Once this complete loop is completed, two things can happen. One is, if the element is present, somewhere in the middle you will have this condition hit. That is, current pointing data at some point will be equal to the target. If it is equal to the target, what will you do? You will return that position, you are done. Otherwise, if you are coming out of this loop, what does that mean? That means you reached a position where current is null. How did current become null? You made current equal to current pointing next. When you keep doing this, at one point you will reach the last node, from where if you make current is equal to current pointing next, this current pointing next is null. This is how your current will become null. So whenever your current becomes null here, that means you are already done with the complete list. You have searched through the complete list and still you are not able to find this particular value. What will you do? You have to return something which says I failed to find the value. So you will return -1. If it is a valid position, you will return the position. Otherwise, if the value is not present, you will return -1. Let us just have a look at this algorithm. Search algorithm. It is having two parameters. One is the head pointer. Other one is the target value. Target is the value you are searching for. Your current pointer, it is going to point to the head initially. That is the first node. Your position will be initialized to 0. Then you will run this loop till the point your current becomes null. That is till the point you reach the end of the linked list. In each step, for each node, you will verify whether current pointing data, that is the data in that node, is that equal to the target. If it is equal to target, you will return that position. Otherwise, you will make current pointing next and you will increment the position. You will continue this. In case it comes out of the loop, that means this particular element is not found in the linked list. That is why you are returning -1. Keep in mind, time complexity is order of n and space complexity is order of 1.